All right. Hey guys, so we can get started. And I guess just before we get started, does anyone want any snacks or prizes? Because it's midterm season and it's really surprising that you all came despite the midterms. And I feel like, we should be thankful and, give you prizes or like snacks or whatever. So anyone want any? Okay.
And it's good. Oh wow, thank you. Thank you. Thank you. Thank you. Yeah. Okay.
All right. I will not move forward. All right. Okay, so welcome to session 3. Today we're going to be talking about backend integration and user authentication. And again, I'm going to be the presenter, and Jaewook and Sam are going to be the other two presenters. So get started. Link to slides, link to Discord. I've also posted the link to the slides in the Discord resources channel, as well as last week's and the week before that's recordings. So take a look if you want. And also more links, link to slide, link to the completed demo, link to the running demo. So I guess just to clarify a little bit, the completed demo is the demo that you saw during the first session that Sam and Sneha made. And the running demo is basically what we've achieved after each session. So if you click on this link right now, you'll be able to see what we did for last session, but not for this session because we are going to be working on it. So that's what the running demo means basically. All right, so curriculum again, we've finished, we're halfway through. We've done intro to full stack mobile dev. We've done databases and servers. Today we're going to be working on more backend integration and other backend stuff. And the next 2 sessions, we'll be going to be moving on to Swift UI, how to make a great front-end app. So again, since I'm the presenter again, we have this stupid GIF that you're going to see again and again throughout this session. But the plan is here. We are going to be talking not really much about what we talked about last time, and then we'll move on to backend integration. I'm going to talk a little bit more about, what is MVC, what is CRUD, what is RESTful API, and I'm going to do a short demo on how to create those controllers. And after that, Sam and Jaewook is going to be talking a bit more about user authentication, basically what is user auth, what are different types of user auth, and what specific type of user auth we're using for it. Go ahead.
I saw on the previous slide, it's week 7.
Oh, because week 7, next week, Monday is President's Day. So we're not going to be having a workshop on that. I mean, even if we wanted to, I doubt if anyone would be here. So, we made we made the most sensible decision to us. But anyways, you're still welcome to come to this classroom if you want. I'm pretty sure we still have it booked, but just be prepared, there will be no one here. Anyways, yeah, so just as an announcement, we won't be having a workshop next week. Instead, we will be meeting again week 8. Hopefully you guys are still coming because I know it's getting closer and closer to the finals week, but we're gonna have some very exciting workshop there. So just keep coming. And again, moving on to the plan, different types of user auth. And again, finally, Sam is going to be adding user auth to our Brilliance app. All right. So last time we talked a bit more about databases. What are the different kinds of databases, relational, non-relational, and we're going to be using MongoDB. We also kind of just created a database. It's empty for now. We're going to be, adding more data to it. But, we've also added the connection string to our app and stuff like that. And also we talked a little bit more about servers. So what are servers? What kind of role server plays in our app? And, finally, a bit more demo on how to create a model in our server. So I don't really have a lot of recap on this as I did last time because we have a lot of content today, but I encourage you guys to, look over our past slides if you're not comfortable with any of these concepts. All right, so backend integration. What we've done so far, we've actually achieved a lot. We've set up the backend project. We've created a database. We've added the database connection string to our project. We've also built I did build one model only, but it was to represent the data stored in a database and using our app. So it's actually a lot that we have achieved, but we're not actually quite done yet, unfortunately. I know I say that every single time, and that's just very unfortunate anyways. So even though we've got a lot of key pieces set up, we've probably noticed that nothing we do right now in a front-end app actually affects the database by any chance. So we can't really create any new data, we can't really update any existing data, and we can't really fetch data from the database to show in the app. So we still got a lot more, or somewhat a lot more work to do. But right now our app is just like that, like the front end and database are just so broken up. So what are we missing? So I guess just to introduce what we're missing, I want to first, talk a bit more about the concept of the model view controller, basically the MVC pattern. So the model is definitely not this model, the view is definitely not this view, and the controller is definitely not this game controller over here, just so that you know. Anyways, so before we actually get into the MVC pattern, I want to take a short detour to architecture. So I guess just as a motivating example, do we all know what we need before beginning the construction of a building? Like an actual building, not like a software building. Go ahead. Yep, exactly. Okay, we need a plan. We need a blueprint. So we need to have these like very smart and probably overworked architects to carefully plan out how different rooms and hallways and like different stuff in the building will fit together to form a functional building before we actually start the construction, or else the building will probably just be kind of fucked up. It's not gonna work. So some things that this blueprint should specify will include, the structure, basically the building's layout, how everything is organized, like where is the kitchen, where is the hallway, where are the rooms, and also its behavior, more specifically how people would move through the building, how they would navigate through the entire building, and also like, how they would interact with different pieces of this building. For example, how would you maybe, move from one space to another? Maybe if you want to go from, the hallway to the room, you need to pass a door or something like that. It sounds pretty straightforward, and it's actually that straightforward. It's how you interact with different pieces. Components, basically these are the, like different parts that we say, the individual rooms like kitchen, bedrooms, office spaces that have different purposes that composes our entire building. So we were talking about, real like actual buildings, but software buildings or software architecture is something similar. So like a building blueprint, software architecture defines the big picture of a software system. So it's not about, like which programming language should I use in this building or this software, or like which specific tech stack I should be using in this software. So it's about the big picture, how different parts fit and work together. Specifically, it also describes these three parts: the structure, behavior, and components. So the structure is about how the system is organized, the overall layout, and the behavior is about how different parts interact with each other. And the components are like these smaller like parts, like the building blocks that combine to form bigger systems. So this is pretty general. We're talking about all softwares and stuff like that, but more generally, we know that each building has its own blueprint. So similarly, there are some, like common styles that all softwares kind of just conform to, with some, of course, unique details and custom touches. So for example, in the real world, a two-bed, two-bath apartment layout will probably look something like that, like one bedroom and one bathroom on one side and another bedroom and another bathroom on the other side. So, and also like, balcony and dining room and stuff like that in the middle. So there are some tried and true patterns that developers use to structure software systems like they do with, like those patterns in the blueprint of the actual buildings. So when I say tried and true, it means that these patterns work well for scalability, maintainability, and efficiency. So scalability basically means that this kind of pattern works both for, smaller apps that we are building and possibly, much larger apps like, Instagram or something. So like that's what scalability means. And in terms of maintainability, that basically means that, if I want to add a new feature to my developed app, or if I want to fix something that has been developed in my past app, that will be, easy to done, easy to accomplish. I don't have to deal with, like the Asian code that no one ever reads or understands. So that's maintainability and efficiency. We all know what that means. It's basically saying that, your app works fast and everyone's happy about it. So yeah, I guess just as a clarification, there are differences between software architecture and software architecture patterns. So I guess the similarity first, sorry. The similarity, they both act as blueprints for system design in terms of software, and they both aim for scalability, maintainability, and efficiency. However, architecture is unique to each system. So I can basically just plot out the architecture of this specific app that I am using right now, whereas the patterns are more, reusable in general. Maybe like these two apps, they have different like details in terms of their architecture, but they're using the same pattern. All right, that was kind of confusing, I would be glad to take any questions, if there are any. If not, we can move on. Okay, sounds good. All right, so that was a long detour, but I guess just as like the final conclusion, the MVC, the model view controller that I was just talking about, is a kind of software architecture pattern. So it's a reusable pattern. It's not unique to any software. So I guess you probably can guess that this pattern breaks into three parts, basically the model, view, and controller. I didn't even set up a interaction activity over there just because I thought it was too straightforward, but hopefully you can see that. The models, we mentioned them last session. So last time I said that, models are this kind of abstract set of rules that our data in a database will conform to. But here it's more general. It does not only represent the rules, the abstract rules themselves, but also represent the actual data. So yeah, basically represents the data our app manipulates, and we've learned how to build these from last session. And also the second part will be views. Views are responsible for presenting the data to the user. So it's what the user interacts with. If you remember it, this definition probably sounds very familiar to how we define user interface. So, what user interacts with. Anyways, we've learned a bit back in the first session, and we'll continue to learn more in the next 2 weeks. So we're not going to be talking about it today, but hopefully you still remember, how to build a very simple user interface in the first session. And hopefully you're excited about how to, build more advanced or complicated user interface in the next sessions. All right, so finally, the controllers. Controllers are like a intermediary between the first two parts, between the model and view. So they have a lot of responsibilities. For example, they handle user input from the view. And after that, they update the model accordingly. And finally, they tell the view to update to reflect the changes in the model. So I guess just as an analogy, it's like the air traffic controller for your app, which directs the flow between the model and the view. I feel like it's not a proper analogy because I'm saying that a controller is basically in a controller, but I'm pretty sure you guys all get what I mean by that. Anyways, let's look like a concrete example. So imagine we're having like, a to-do list app again by our hand. The model part will be handling the data. So basically, it could refer to the database or memory where all the tasks that we have in our to-do list are stored. And the model stores a new task whenever we add one, and the model updates when a task is marked as complete from, if it's being marked from, incomplete to complete, something like that. On the other hand, the view is responsible for displaying the data, basically, again, what we see on the screen. So the view will basically update when we mark buy groceries as complete. Maybe my user interface is such that, before I mark it as complete, there will be like an empty checkbox. And after I mark it as complete, I will see, like a checked checkbox, something like that. So finally, the controller handles user interaction or user actions. So basically, when we click on add task, the controller tells the model to save it. If the controller is not there, the model won't really do anything. It won't really be aware that the user clicked on that task. And similarly, when we click on complete task, the controller is, I guess the role that tells the model to update the task and then tells the view to refresh. So again, if the controller was not there, the model don't really know that it needs to update the task, and also the view won't really know that it needs to update the view or what you see basically. So this is a pretty simplified diagram of this model. Basically, we have the controller in the middle, and the controller has this bidirectional interaction with both the view and the model, whereas there are no direct interaction between the view and model itself. So basically, if you like just remove this controller, if you kind of just cover it up, you will see that we have two separate pieces of our app that don't really know what each other is doing. So this is another graph that's a bit more involved, and it involves the presence of a user. So we can go through this graph in a order of a usual interaction between the user and the app. So first, the user will send a request. For example, this request could be, give me all the tasks that I have right now. And this request will be sent to the controller, and the controller will be requesting the data from the model, basically asking the database, hey, I want all the tasks that is in my database right now. And the model, upon hearing that request, will return all the data that the controller asked for. So, here's the task that you asked for, like, there we go. And the controller got that return data, and it will send that data to the view, to our front end. And the view is like, okay, I have an update. I need to show this to the user, and the view will render that result back to the controller, and the controller sends back the user with a response. So that's like a overall flow of a user interaction. And that kind of interaction just happens probably like millions of times every single day. So it's like, this loop back and forth, back and forth, and back and forth. And the user might also, do something based on what is like, I guess, what is responded back by the controller. So anyways, questions? That was kind of fast. Yeah, that was kind of fast, very fast. Okay. Okay, hopefully we don't have a lot of confused audience over here because I feel like when there are no questions, it's not a good sign, usually. Or we might have a specifically cracked audience over here for this session. Anyways, hopefully it's the latter, but we are ready to move on to the next topic of today, which is CRUD. So hopefully, or not, it doesn't really matter. But anyways, maybe a lot of you guys have already heard of this concept before, so bear with me a little bit if you have. But this is a really important concept in software development or in terms of mobile development or web development. So yeah, does not hurt to hear it over again, I guess. So going back to our app, we have our model. We defined how our data should look like. We created a MongoDB database, and we added the connection string to our app. And I said, we will be later on building our view. So what are we still missing? I will be very surprised if I had to make this an actual interaction that I have to prompt you guys to answer, because hopefully you still know that we're missing the controller part in our app. MVC, we have the model view. We're still missing the C part, which is the controller. So I guess to actually build that controller, we want to first kind of get a sense of what we want to do in our app. So we're building Brewing Eats, which is like, a review on restaurants. So I found this Yelp screenshot, which might represent a little bit of what we want to achieve in our app. But over here, you can see that, this is a restaurant called Sonongden, and there are some reviews. You can write a review, you can add a photo, and you can see all their information. So similarly, we have the following items that we want to achieve in such a app. So for example, we want to, write a review for Bplate. That will be something that's similar to a create option. So we're creating something new. We're creating a review. And on the other hand, we could, we don't really want to write a review. Instead, we want to look at other reviews for a specific place, like House of Meatballs. They have really great meatballs. I just went there. But in that case, that will be a read operation. We are only interested in reading the data. We don't really want to, create or modify or delete or anything. We just want to take a look at it and we want to learn something from it. And I guess the third operation that we want to achieve is to do some update. So this could include maybe, change my rating for Mr. Rice from 0 to 5 stars just because I found a really great dish over there. Or I could also just want to change the content of a specific review that I wrote. And finally, of course, there's always the delete option. Maybe I want to delete a review because the place like Meat Fresh is not there anymore, or I'm threatened by the shop owner to delete my review. But I could also be, deleting my account or something like that because I don't really want to use the app anymore, and I don't really want the app runner to have my personal information after I delete my account. Anyways, so that will be the 4 basic operations that we typically want to have in every single software or every single application that we write. It will be very hard I feel like I've thought about this before, and I can't really come up with a single example where there are some of these operations that's lacking in a specific app. But let me know if you found one. I will be very surprised. So these are the things that we want to do in our app, but not just in our app. These are create, read, update, and delete. And if you take the initials of all these words, that makes CRUD. So these are the key operations in software development. And if you're interested or not, if you're interested, we're going to be covering them. We can implement this in a lot of ways. And the specific way that we're going to cover in this workshop is by using something called HTTP. So what is HTTP? HTTP stands for this thing that I don't really understand what it means by myself, but it's Hypertext Transfer Protocol. It's a very important or dominant protocol for transmitting data. This data could, involve a lot of different types. That could be web pages, images, videos, stuff like that. And this data is transmitted between clients and servers on the internet. So hopefully you still remember the concept of clients and servers from last session. But protocol here means a set of rules and standards. So I guess just as an analogy, it's like a language that all devices kind of follow to communicate effectively. So if we don't have this protocol, if we don't have this set of rules, each computer or each app will be just basically talking in their own languages. And you know what it happens, people won't really understand what each other means, and there won't be really any useful transmission or communication between data or between the apps. So this is how a typical HTTP request on the left and HTTP response on the right will look like. I'm not super sure if you guys can see it, but in the boxed red part is the header of the request. So it's composed of these parts. So it starts with something called a post, and then slash and HTTP 1.1. That means the version of the HTTP. And there are more information that comes after. We won't really be interested in these information per se, but if you take something like some other classes, maybe you'll be required to understand what that means. Anyways, as for the response, it also starts with something like a header, also starts with, the version of the HTTP. But, like what comes after is a bit different. There's like a 403 thing, and it says forbidden. I was trying to look for an example that has 404 because that's what everyone is kind of more familiar with, like 404 not found. But, this works probably just as right. But so this is a number that's kind of represents the state of this response, and we'll be talking more about it in later slide. So yeah, there are a lot of other stuff that comes after this response that we're not particularly interested in for this workshop, at least. And yeah, and more, empty line, buddy, stuff like that. Okay, so I guess just to talk a bit more about HTTP and HTTP request methods, there are four major types of HTTP request methods. So the first one is called get. Get is specifically used to get data. So to read data, I want to retrieve some data, see some data, take it and analyze it. I don't really do anything that changes it or updates it. That's when we use get. And another method is called post. So the post that we see here, it's used for updating state of the server by sending data in a more, I guess, practical way. Basically, if I want to edit my review, if I want to edit my rating, I'll be using a post method because I'm trying to edit a existing piece of data in my database. So that's a post. So put request will update status of an existing resource. There are some confusion between these post and put. And sometimes they are used interchangeably, but it's not a good, I guess, strategy. So I guess my personal take on this is that I use post to create like new entries in a database. And for put, I'm using it specifically for, editing resource or editing existing, entries in a database. I know some people who would use post to edit existing resource, but I don't know. It depends on, what your manager says and what your specific use case says. Anyways, finally, delete. There are no confusion over there. This is for deleting a resource or deleting a certain entry in a database. So there are more HTTP request methods that we're not particularly, again, interested in, but you can click on this link to see all those methods. You can see there are a lot more like patch, trace, option, connect. I've used patch and I've never used the other three. So I guess, these are the four like major, these get, post, put, and delete are the four major types. And sometimes you would use patch. For the other ones, I don't really know. I haven't really seen anyone using it. Anyways, going back to our slides. Oops. Oh, wait. Anyways, so that was the request message, and we want to actually dig deeper into there. So we want to see how do we make a request. So aside from specifying the request method, we have some other components that we will add or append to the method. So first, again, method, what will your request do? Get, post, put, delete. And after that, we will append the method by the endpoint plus the host. Basically, this part specifies where this request will be done. So the endpoint will look something like this slash profile thing. This basically specifies that, this resource or this kind of data that I am requesting for is profile. So the resource being accessed. And then the host over here, I have localhost 8000, but over here I have localhost 8080. It's just different URL, means probably the same thing. And it basically specifies the server address where this request is being sent. So over here, I'm trying to send the request to localhost 8080, and in the previous image, I'm trying to send the request to localhost 8000. So that's the difference. I guess that's the only difference between these two requests. And what happens after sending the request? Probably getting a response, right? But we'll be talking about it later. So these are some examples of the HTTP request endpoints. So create corresponds to post. So create a new task will be post/tasks. So slash looks like a path or a URL, and we usually use that format to specify, which resource we're trying to access or trying to create. So over here, I want to, create a new task. So it will be /task. Okay, /tasks. And in terms of delete, we want to delete an existing task. But when we are trying to delete a specific task, we will have to specify which task we want to delete. So we'll be specifying that by having this /angle curly bracket ID curly bracket thing. So in the real in the real world scenario, we'll be replacing this curly bracket with the actual ID. So maybe the task that I'm trying to delete has this ID called 1. In that case, it will just be /tasks/1 with the delete method, of course. So that was delete. And for getting a specific task, it's something similar. We'll be using the get method, and we'll be specifying the kind of resource, which is tasks, and we'll be specifying the specific task using the ID. And another get method will be only /tasks without the ID. That basically means that we want all the tasks in our database. So we don't really specify anything. We're just specifying, we want everything of this kind, just giving back everything. And finally, update an existing task. Again, we need to specify which task specifically we want to update. So we'll specify that by using the ID, and we'll be using the method called put. All right, so that was the request part. And after the request, we need another part called the response. We won't be really writing all these responses, or not a lot of them. We'll be mainly caring about the request, but we do want to know at least what's going on. And if there's something that's not, that's kind of off, we want to know exactly what is off. So a typical HTTP response, again, looks something like this. There will be some information in the very beginning, and followed by something like a web page or some other data. So if you can see, so it starts this HTTP response. It starts with HTTP/1.1. That means the version number, and followed by this 200 OK. So that's something that's similar to the 403 forbidden that we've seen earlier, and also similar to the 404 not found that we've always seen in our daily lives. So that's called HTTP status codes. So these are just numbers, 3-digit numbers that tell us the status of our response. So if it's good, if it's bad, if bad, how bad it is, why is it bad, or something like that. So typically we're most interested in these 3 categories. So the response or the status codes that started with 2 or 4 or 5. So 200 or 2 and followed by 2 other digits basically means success. So there might be different sort of success. The most straightforward one is just a 200 OK. There might be other ones. And also we have the second category is 4 followed by 2 other digits. That basically means, you're doing something on your end. If you're a client, you're sending a bad request. Maybe it's formatted, not as optimally, or there's something wrong that you've done in that process. So that basically means, bad client request. And in terms of 5 followed by 2 other digits, there's something wrong with the server. So something in the server is not working. It's not really your fault. Maybe you've written the perfect request and there's just nothing that you can do. Or you can do something unless you can do something if you're developing the server. So in our case, if we see a 500, we have done something wrong in the server development.
Okay, pause. I just want to do a quick quiz to make sure that you guys are all paying attention.
That's crazy.
So,
I was not prepared for this, guys.
it should be really easy. So does anyone know what HTTP request method you use to create a new object inside of your database? Yes. Correct. You get a prize. Um, does anyone know what are the three
Preference?
HTTP requests? Anybody? You want to go back and just review?
I am. It's taking a while though. Oh, oh yeah. Yeah, like she said, post is for creating data or sometimes modifying data. Put is for mostly updating data, and delete is for deleting, and get is for retrieving, reading, getting data.
And there's three parts to an HTTP request. So there's the
It's going.
status, there's the request line, like the actual request, and then there's the header, and then there's the body, right?
Oh, I thought you were still quizzing them.
No, I am quizzing them.
Oh, you are.
So what's the three parts of an HTTP response? Does anyone, I'll give you a hint, it's very similar to the request.
It's literally up there. Good.
Okay, so it's the response line, and then the headers, and then the body. So just remember that. That'll help you a lot.
Yeah, exactly. Just remember, I guess, everything that's boxed over here. In terms of everything else, like the server, the content type, the date, we don't really care about those for our session at least, right? Okay, he's not replying. Anyways, I'll take that as a yes. Good. Thanks for the quizzing. I should probably move a bit slower. All right, but we'll get back to where we left off. I'm pretty sure we're at response. So again, we have the header, we have the HTTP/1.1, we have the 200 OK, we have a lot of other information like date, like content type that we don't really care about. And finally, you have the actual data that is being transmitted back to us. So over here, it's a web page that has a title called an example page and has body called, hello world. This is a very simple HTML document. Right, might be a bit hard to see, but yeah, again, the status codes. Usually we just read the first digit first, and if we see a 2, that means we're good. We don't really need to care a lot about our program. But if we see a 4 or 5, something is not going right. And because we're both developing the front end and the back end of our app, that means something that we've done must have gone wrong. So you can't really blame that on some other developers because you're working on both sides of the app. So if it's 4, that means something is wrong in your front end or in the request that you're sending. Or if it's a 5, that means something is wrong in your server. Maybe your server is not handling that request correctly. Maybe your server is not taking in that request correctly. So something's wrong and you need to fix that. So yeah, I guess from the very beginning, we said that we will be implementing CRUD using HTTP. So I guess more specifically, the way that we would do that is we're mapping each operation in CRUD to a specific HTTP method. So create necessarily maps to post, read basically maps to get, update maps to put, and delete maps to delete, of course. So over here is the CRUD operations, and over here are the HTTP methods. So it's a one-on-one relationship, and it's pretty easy to grasp. So that was all of CRUD.
Wait, quick quiz. So what is the HTTP method that relates to update?
What?
Correct. Great.
Guys,
Great job.
question mark? Do you want any snacks?
What's your name?
Bro.
Oh, okay. I'll write it down.
Why do you have to write it down when we can get in the price like right now?
Oh, sure. Either way, okay. And then one more quiz. What is the HTTP method related to delete? This is not a trick question. Yes, yes, you're
Nice. Very good, very good. Yeah, I guess the most important graph or concept of this part is just this mapping between CRUD and the HTTP method. And as long as you get that, you're good for, our next parts or this entire session. Okay, yeah. So, moving on, we'll be talking a bit more about something called RESTful APIs. So that concept might also sound very familiar to you, especially if you're trying to kind of just get your resume through that ATS test of a lot of, companies' application, because a lot of times people will be looking for tools like, I've developed the RESTful APIs, or I have, implemented it, or have, improved on existing RESTful APIs. And maybe you were thinking about, what that even means. So we're going to be talking a bit more about what that means. And I guess just before that, this is something from last session, but is there anyone who can tell me what does API stand for? Exactly. Yeah, this is a particularly important, concept, and we really expect, or it's not we really expect, you guys are really expected to know its full, like the full representation. Even though you like, you should like remember the full representation, not just the synchronous API. So application programming interface, and it particularly provides a set of rules and protocols for how one piece of software can request information or perform actions on the other system. So I guess this might have been a bit confusing if you're just reading a concept like you're doing right now. But if you were at the last session, I think our officer has provided a very interesting graphic, or I think she was using what, like a selling machine or something like that, analogy, and that was really fun, and I feel like that made this concept really easy to understand. So I recommend, going back to the slides if you're not sure what API does. So we've been talking about APIs last session, but I said that for this session we want to talk about something like RESTful API. So what that means is, okay, so first, what is REST? REST stands for Representational State Transfer. Honestly, this one, I'm not super sure if you have to remember or memorize the full representation, because honestly, I don't even remember it. But REST is basically a set of rules for building the APIs. So remember that discussion of the software architecture patterns that we did earlier. So it's more like a generic pattern that you can use in a lot of designs or discussions. And basically, this set of rules will make communication between our apps and systems simple, scalable, and efficient, basically corresponding to, the maintainability, the scalability, and the efficiency that we talked about earlier. So REST is a set of rules, and REST or RESTful APIs are APIs that follow that set of rules. So you might see that I have put a set of parentheses over full. That means, or I was trying to say that you can use REST APIs or RESTful APIs interchangeably. They mean the same thing. And I don't really think there is a preference in the industry about, which one I should use. People usually get your meaning no matter which one you use. So feel free to pick your favorite, but one characteristic that we are particularly interested in terms of RESTful APIs is that they have a uniform interface. So our data are accessed via endpoints with standard HTTP method. That might sound a bit abstract, but in terms of this, you've seen this in the earlier slide, but just to reiterate, in order to get data, you'll be using something like get/tasks. And to create will be post/tasks, and update, put, remove, delete. So everything should look like this, no matter what your implementation is down, like, the bottom. In order to have everything work, in order to have your API conform to this standard, you'll be required to provide this standard interface. So I guess that was a bit abstract, and I kind of used some terms that's always using upper div CS classes. So
quick question. Which upper div CS class
really,
talks about this?
really, is there any class that talks about this?
Yeah.
Oh shoot. I have my guess, but I'm not sure.
Does anyone know?
Okay, Jenna is saying 144. That's definitely not the case.
Hmm, partial.
I mean, 144 is not something that everyone will take, but I'm pretty sure he's referring to something that everyone will take, like a
Yeah,
required class or something like that.
okay. It starts with 11.
11?
Yeah. But it starts with 1, 1. There's only one other.
One, one.
Really? Can't be one
no,
one.
1 is OS, right?
Yeah.
Yeah, 118.
That was not on there.
Is it?
It was not on there. I took Varghese. He did not talk about application layer at all. Not at all.
Oh, what?
Anyways, he was just yapping. He was tripping. Anyways, yeah, I think now if I have to say, I feel like 35L might be like, touching the surface of this concept, but I'm pretty sure Eggert won't spend too much time on this, even though he did spend any time on this. So, but anyways, it's still a very important concept, and it will help you a lot in your career or in your study if you do understand what that means. So I guess the last time, does anyone have any questions about what RESTful APIs are? Yeah. Okay. So we've been talking about the MVC, we've been talking about CRUD, we've been talking about RESTful APIs, but that just sound all irrelevant to our app. So I guess reminder that I said we still need to build the controller of our app. So how does that work together with the RESTful APIs that I just talked about? So in our specific case, in our app, controller are specifically the controller classes that we're going to be coding in a moment. And those classes provide the code behind our RESTful APIs. So the RESTful APIs are more like, like the conceptual idea, the rules, or like how we want it to work. And the controller classes are like the actual implementation, like the thing that's actually supporting it, the thing that makes everything happen. And yeah, so in our Swift UI app, there are collections of methods that accept a request and return a response. So that's basically, serving as the intermediary between the database and our front end. So everything is under control and under controller. And yeah, I guess final thing before our demo. Any questions? Any quizzes? I guess not. Okay. In that case, we can move on to actually create those controllers. I know you guys have been waiting for this for so long and I've been yapping for too long, but let's just move on. Oh,
From the beginning. of the
Okay.
slides. So just to make sure you didn't forget, so what is the app architecture or the design architecture pattern that we're using? Does anyone remember?
Wow, I'll be very sad if no one remembers. I've been yapping for so long.
Yes. Correct.
Yay, nice. Okay,
You get a prize.
if you want any prizes, okay. We should get better prizes next time. Anyways, if that's the end of the quiz, and if no one has any further questions, we can move on to some coding. So it's gonna be a pretty short coding. We're just gonna be implementing some like very basic request or response method or prototypes. But yeah, it should be easy to follow, and let us know if you're kind of wondering about anything or not following at any time. So I guess the first thing that we need to do is, again, not to write the code itself, but to create something, create a container that include or contain all of the code, for better organization of our code base. So the first thing that we want to do is create a folder called controllers. So we will be like, storing all the controllers that we have built in that folder, and we'll be working on that folder. So I have my controller created over here, but your folder should, be under this. So if you click on expand, it should be under first app and expand again. You can create a folder called controller. So you can create a new folder in Swift or in Xcode by right clicking on this app, and there will be something called a new folder. And if you click on it, oh man, okay, there will be a new folder. Okay. Anyways, okay, never mind. So yeah, I have created this controller folder. And the next thing that we want to do is create an empty file called restaurants controller. So restaurants controller is specifically responsible for handling these CRUD operations on the restaurant items. So you probably can imagine that we will be having more controllers like the user controller that handles CRUD operations on our users, and also review controller is responsible for maybe adding a review, editing a review, or deleting a review. But restaurants controller is probably the easiest one to implement, and that's why we're choosing to implement this restaurant controller in our demo. Anyways, so this is the empty file that I have created before this workshop, and we're all set and we're ready to code. So the first thing, again, is the most important thing to do imports. So the imports is not really any different from any of the previous import that we have done. So I'm just gonna actually copy this over to here. So we need foundation, we need vapor, we need fluent. These are technologies that we've introduced probably a couple of times before in this workshop series. And if you're not super sure what that means, ask an officer or go back to our previous slide. And there is one more thing that we need in terms of this specific file. We need something called Fluent Mongo driver so that our app will be connected to the MongoDB database. So I over here. So these are all the 4 inputs that I need for this specific code file, and we're ready to start coding the actual controller class. So as I have always said, the controller class, the controller class, the controller class, the controller is a class. So we will be defining that with the class keyword. And we'll be naming it using restaurants controller. So basically, the file name. And the controller conforms to this interface or type called route collection. So basically what that means is that this specific controller is able to group different routes together. So it's not like, there's a route over there, there's a route over there, and they're all separate. It's able to collect different routes together and, deal with a specific group of requests. So yeah, okay, so that was the declaration of this class. Yeah, I have nothing in there, so there's an error over here right now. But we need to write first something called a function that is named to be boot. So boot is just this function where we define these routes and associate them with the controller functions. So basically, this function, we will be using the standard syntax in Swift UI or Swift to define a function. So func. And we'll be using routes. Oh. And routes is of type routes builder. So don't really worry too much if you don't understand that class. It's just a set of tools that's provided by Swift UI that we can just use without knowing what's working underneath it. So it's like a black box. So throws. We want to define first a variable that stores our API. So we want to let API be the routes group. What that means is that basically we are trying to group all these routes together, group all these routes that starts with API together. So that kind of just calls back to when I was explaining route collection, saying that, it can collect different routes together. So we're here grouping all these routes that start with API together. And then we are ready to define some controller functions. So we have 2 controller functions over here, or not 2 controller functions over here. We're ready to define the routes. We have 2 routes over here. We have a get route, we have a post route. So I imagine in an actual working app, there might be more than these 2 routes, but for, like the demo purposes, I'll just be, writing these 2 routes. So for the first route, for the get one, I'll be having some path that looks like this, /API/restaurants. And the post will actually have the same URL that is, API/API/restaurant. And we will be able to distinguish between these 2 requests because we have the different request method. So over here, it's get, over here, it's post. So these are the 2 requests, and our program or our app or our server will be able to tell, which line of code should I execute if I get a request that looks like that. So first we'll be implementing a get, and I guess just to write again, it will be looking like something like this, API, and
Operation is get, by the way. We,
exactly, nice. Yeah. That's always the first thing that we implement, or like the first route that we add to a controller, because you need get, and usually get is the easiest to implement. So in our case, we will be implementing this route with this function called index that we have not defined. So after I type it out, you will see an error, but don't freak out because that's not because we did something wrong. That's just because we have more work to do. So the code that we have to write is just called API get. Here we're using the get that corresponds to the get method over here, and get we'll be getting restaurant specifically, so we will just be putting restaurant in the code, in the code, and when we specify the function that we want to use, we will use something. We will write in here. So use column index. So yeah, no exact matches, or yeah. So over here, I don't really have anything called index, so that's why I'm having a lot of errors over here. But once I, like actually write the code for an index function, it'll be fine, hopefully. Again, that was the definition of the get route, and I guess the definition for the post route. Do you have a quiz on that? If not, okay. It's the same. Yeah, it follows the same syntax. We'll be calling API, and instead of get method over here, we have the post method. So the keyword should change also to post. And we're still, posting under the restaurant category. So post restaurants, and be using another function called create. So yeah, more errors over here because I don't have that defined at all. All right, so that was the first part of our controller. And again, I guess just to go over everything. The first statement, the let API routes groups, it groups all routes under the base path /API. So, I have /API restaurants, maybe I'll have more different routes, but they all have the same starting /API. And over here, this route calls the index function to retrieve a list of all restaurants. And the create function, or this line with the create function, it calls create to create a new restaurant. Pretty self-explanatory. So yeah, we're ready to define these two functions that we're using here without, we've been using it, assuming that it works, but we have to actually write it ourselves. So the first one will be the index function. So I have a lot more comments on there, but I'll be going over them later. Let's just first write it. So yeah, that was the function boot, and after function boot, we want to write the function, I think it was called index, yeah. So specifically, function index takes in an argument, that's the request. So the request is we name it to be REQ, and the type is request. And it would be a async function. We are not really explaining what async means in this workshop, so don't really care too much about it. But if you are interested, maybe you can, ask one of our officers, because it's a pretty interesting topic, and we'll be willing to, just explain it or like tell a story about it or something like that.
I'll explain it later.
That's not even this. Okay. Okay, do it. Because I like the concept. I think it's fun. Anyway, so that was the async definition, and we want to also just define what kind of response we will be kind of expecting from calling this function. So we will be specifying with the throws arrow, and over here we will be retrieving, or we'll be expecting to retrieve to get back a list of restaurant. So we'll be using this array representation with the scrap bracket. So it will be restaurant. And yeah, so that was the function definition, or the first line of function definition. And for the body, we just really need one line over here that says try away restaurant.query on recdb.all. That might be a bit confusing, but I can explain that in a bit. Yeah. Anyway, so again, going back to definition, the first part in the parenthesis basically means it takes in an HTTP request as an argument. And async means that this function runs asynchronously. Sam is going to talk a bit more about what that means in a second. And throws means that if something goes wrong, it throws an error. So we will be able to catch that error and see, what is going on. And finally, the arrow restaurant with angle bracket means that it returns an array of restaurant objects. So yeah, so inside the function body, we will do a try, await. So await corresponds to the async keyword. That basically means that our program will wait until we get back the response. Until then, it won't really do anything. So await, we will be waiting on a restaurant. So we'll be waiting on restaurant dot query on. So there's like automatic filling. I love that. Anyway, so we'll be query on this database that's specified in the request. So it's gonna be rec.db. And since we are trying to retrieve all the restaurants in our database, we'll be appending this query with a auth. So if you don't have it, you might not get the entire list of the restaurants. So that's actually pretty straightforward. It's just this one line function or one line body over here. So yeah, I think again, auth fetches all the restaurants. Try means that if it fails, it throws an error. Wait waits for the database to return the results before continuing. Okay. Right. Okay, I'll be yeah, I have the slide that that resolves that error in 1 second after we have finished the definition of this class. So that was the index function. We still need to define the create function. So basically it will be of the same or similar format. So func create, and so it will take in a request. And it's also async. And we also expect it to throw a error if anything goes wrong. But the return type is a bit different. So because this function is responsible for creating an object, we kind of want to have it return the newly created object so that we can take a look at it and make sure that everything works. So instead of the angle bracket restaurant over here or the square bracket restaurant over here, we'll just be returning a single restaurant. So over here. And inside the function body, it's also a bit different. So the first thing what we need to do is to do this thing called rec content decode. Basically what that does is it reads the request body, it reads the parameter, it reads the argument that we are passed in and converts it into a restaurant object. So when the argument is passed in, it might be in like a really random format, or it might not be, it's probably not in the restaurant object format, but we really want to have our database store all restaurant objects. So the first thing that we need to do is kind of just do this format transformation to make sure that, the data types align and everything is like perfect and better organization for our database. So yeah, the way to do that, it would just be let restaurant. And again, we'll do a try. And specifically what we are going to try is to try this decode. So rec content decode, and we'll be decoding it to restaurant.self. So basically specifying that, we want it to be a restaurant object. Okay, after the decoding, we're ready to, save the new object into our database. We are ready to create a new object in our database. So again, we're going to be doing another try. This time we're going to be doing a wait. So this time, wait. Oh. So instead of query, we want to do a save. That basically means that we want to insert this object and save it into the database. So the syntax is actually the same after it. So on recdb, and yeah, so that's basically just saving the restaurant in the database. And finally, we'll be returning the newly created object so that we can, examine it and see if everything works. All right. So that is actually the full definition of this controller. but there are still some errors that we need to resolve, and it's actually a pretty easy fix. All you need to do is just to go back to our model's definition over here. So last time we wrote something, like this, and ignore this warning. It doesn't really matter. But anyway, so one thing that we need to add is just to, after this model, add something that's called content. So the only
You can get rid of it by adding at unchecked sendable.
yeah, but I guess okay, it's not related to anything that we talked about, but yeah, if you wanna remove it, at unchecked,
Or
unchecked.
like the email at symbol. And then unchecked. And then capital S sendable. Space between those two.
Yeah. Okay, so I guess we might or might not explain what that means, but if you want to get rid of the warning, you can add that as well. But in order to, okay, let me just refresh. Yeah, so the error is gone. We still have the warning that is not really breaking our code. I don't know if you want to fix it.
Oh.
We can, but
What is it?
it's the sendable thing again. I mean, we're not gonna have race conditions here.
Okay, no.
Okay, anyways, the error is gone, so we're all good. So the only change that you need to do, is just adding this content, and if you want, add this unchecked sendable in the model definition of restaurant. So yeah, we are actually done with building the controllers part and this demo, and I'm done with my part. So actually, we can move on to the second part of this workshop, which is user authentication. And Jaywood can talk a bit more about, what is user auth and what is the specific type of user auth we're using for this session.
Okay, hello everyone, my name is Jayup, and today I'll go over the user authentication and user authentication using token with an example of signing into my UCLA website. So a user authentication is a process of verifying a user's identity in apps, and it is commonly used in apps that requires login features. For example, it could be a banking app, e-commerce app, social medias like Instagram, Facebook, or even with my UCLA website. Okay, so we have went over what a user authentication is. And we have some different types of user authentication. And I listed some examples here on the slide, but before I show like all the examples, can some of you maybe come up with an example of user authentication for the price? Anyone? Yep.
Netflix login.
Yeah, that could be a ID and password-based login. So we actually have password-based login, which requires user ID and password, biometric login, such as fingerprint or Face ID, two-factor authentication, and token-based. I'm pretty sure like everyone here are familiar with the first three examples, but does anyone know what a token-based user authentication is? Okay, great. Now I'll explain how a token-based user authentication works with an example to signing into my UCLA website. So let's say my goal is to signing into my UCLA website with my UCLA account. So I go to the website, type in my ID and password, and click that blue sign in button. That way, I'm sending my user ID and password to the server. Now, with this data, what the server will do is they'll verify if my user ID and password was indeed a correct information. For example, if my user ID would actually match with with the user in the server, or my password actually correspond with my user ID. So let's say in this case, I made a typo and say I typed in incorrect password. So now the server will tell us that this input was actually wrong. For example, it'll return an error message that says the login request you submitted is invalid. Okay, so now I realize what mistake I made. So I fixed the password to the correct one and send it to the server again. Now the server will do the same verification process as last time. And in this case, since I provided the correct information, the server will approve my request. So after the server approves my user ID and password, it'll give us back a thing called token. But what exactly is a token? A token is a string that represents the user's identity, permissions, and other important data. This is a unique identifier for a user, and it contains necessary information such as user ID, what permission this user has, and also when does this token expires. And also this token string is encrypted with a cryptographic signature using a secret key for the authenticity purpose. So since the string is encrypted, it might look something so random. So it might look something like this. You can see like there's no pattern. It's so random, right? And we have this thing called JWT, which stands for JSON Web Token, which is most commonly used token type. And it is consists of three different parts: header, payload, and signature. And each of them are separated by a single period. The header includes information such as how this JWT token has been signed and what the type of this token is. In this case, since you're using JWT token, we say JWT is the type of our token. And after encryption, we get a random string for each header, payload, and signature. And for this example, I made it so that the header part, the string for the header part starts with AAA, so that later on it's kind of easier for us to distinguish between header, payload, and signature string. But in most cases, those string would be more random. Now moving on to the payload. Payload includes a thing called claim. Now, claim in JWT token means data about the user and additional important data. For example, it contains issuers, subject, and expiration time. Issuer would usually be the server. In this case, it would be my UCLA website. And subject would usually be a user. In this case, ACM hack ID. And lastly, the expiration time. And let's say that we got some string that starts with BBB for the payload part. Now moving on to the signature, I kind of prepared a pseudocode of how the signature could be created. So we first indicate which encryption algorithm we're going to be using for the signature. And then for the arguments or the inputs, we put a string that is a combination of header and payload and a key that we used to encrypt this string. And let's say that we got a string that starts with CCC for the signature part. So now we got all three parts of the JWT, header, payload, and signature. And following the format on at the top of the slide, we get our final JWT token as something like this. Before we go back to the my UCLA example, does anyone have any question? Yeah.
So the signature also uses the header and payload?
Yeah, signature takes header and payload when it is being created. Okay, so here we came back to the MyUCLA website example. So we have successfully logged into MyUCLA. And now let's say I want to log into I want to go to the class planner page to check which classes I'm taking and when those classes are located at. In this case, do we have to send our user ID and password to server again to get this information? No. What can we use instead? We got, yeah, we got token from the server, and we can use this token again to prove or verify that we are a verified user to the server. So now we're going to send the token back to the server, and the server will check whether the token is valid and whether the token has been expired yet. So this could be an example of like server sending a warning message to us saying the token would expire soon. And when the token is expired, we will automatically get logged out from the UCLA website and our token is expired. But let's just assume that our token was indeed valid and our token has not yet expired. So now the server will approve our request to get the class banner for our account. And as a result, we can see which classes we're taking for this quarter. Does anyone have any question for the token? Okay, great. Now Sam will talk about how to integrate token to our project.
Yes. Okay, so far we've created a controller for our restaurant, but we haven't created a controller for our users, and we haven't created a JSON web token inside of our Xcode. So let's go ahead and do that. And by the way, I know that David covered this, but just so you know, when you're sending a HTTP request that requires the user to be authenticated, you will put your token inside of this header called authorization, and you'll prefix it with bearer, and this will allow you to access any endpoints that require a JWT token. Okay, so let's go ahead and test that out. Okay, so first of all, in order to do some authentication, we probably need to create some users. So I'm going to just quickly set up a user model. All right. And this shouldn't be like too uh difficult for you guys to like do. I mean, you can also check our GitHub for the exact code for this because I'm not focusing on building the model right now. So I'm just going to put it here. Um, Actually, I'll just copy it from the GitHub. Right. So what this does is this creates a collection of users inside of our MongoDB database because we're following the model protocol, which is from Vapor, which allows any model that we create to become part of our database. So we'll have an ID, username, password, and then the user is created using these three fields. And this just makes sure that the password is valid. You don't have to actually have this in your model if you don't want. But now let's actually go ahead and create a model controller. So we're going to create a users controller. All right. So I'll import the same things as we did with our restaurants controller. And then we'll create a class. So this is a controller that once again is going to be extending route collection. So we'll create some routes. So what routes do we need? Well, we want to, first of all, create a user. So we'll call that register. And then we'll also want to log in. So we'll call that login. Okay. And then remember, when we have a route collection, we always want to create a boot function. So we'll do that. And then let's go ahead and first put these under the API endpoint because that's what we did over here. So I'm just gonna kind of copy this boot function and then adjust it for what we're doing right now. Okay. So we have a register route and then we have a login route. And both of these should be what type of HTTP request do you think? Does anyone know? This one is wrong, by the way. Nobody knows? Okay, well, it's gonna be post as well, just so you know, because we're creating an object inside of our database. Okay, so we're gonna define a register function and then a login function. Cool. So first of all, let's create the register function. Okay, so this is gonna be a lot of stuff. And I will tell you about async. Actually, let me just tell you about async right now as I quickly put this in here. So we label any function as async if inside of the function we use the keyword await. And what await means is that we're going to be calling something that could take a lot of time. And so we want to label it. Normally, await is when we make an HTTP request. Okay, so I'm going to just put it like that for now. And then let's see. Okay. So first of all, we want to decode our request, right? So in the same way that we have it over here, we want to do that with our registration request. So let's call this user, and then we're going to decode our register request as a user. So what this means is that later on when we test this endpoint, we're going to be sending in a JSON to as our body to this endpoint containing the username and password for this user. And so that can now be decoded into an actual model object inside of our Swift database. All right. And then now we actually want to um, save this user into our database. So we'll save it on our DB, similarly to how we did over here, right? And then we can return user. I mean, that's a valid thing we can do. And for now, I'm not going to put in logic to like check if this username is already taken, but we would want to put some logic for that there. So you can notice I'm reusing a lot of code, which is a good practice, by the way. Okay. Um, so now let's create a login function. Is everyone with me so far? Yeah. Okay. That's great. Um, so similarly, we want to see if we can decode a user from our request. And then now we actually have to query our database to see if, the password is correct. So I'm going to type a lot of stuff here, so just bear with me. First of all, we want to map the user that we decoded to an actual user inside of our database. Okay. So what I'm doing here is, why did I put guard here? Because this could throw an error, right? If we find there's no user in our database. And so we don't want it to actually like break our code. Okay, so we're going to query our database. And then how are we going to do that? We'll filter for a user that has user.username. And then we'll just take that user because in case if there's multiple of the same username, we'll just take the first one. All right, and then we had a guard. So what happens, like, if this doesn't work out? Well, we can return some sort of like response. So for now, I can just return user, but later on when I talk about DTOs, we can fix this. Okay, so assuming this works out, we actually got an existing user. Otherwise, it'll return some sort of like meaningless data. Okay, so now we have the user, so we also want to verify the password. So let's call password dot verification on our user. And this is something that we can do because if you look over here, we have the validatable protocol that we're following. And so that means that we can call this built-in verify function. So we can do that using this line. So now we've successfully checked whether or not the password is correct, and this is a Boolean. So if it's not correct, then we want to return some sort of like incorrect object. And for now, we'll just return user. Okay, but if it is correct, we'll keep going. And now we're going to generate our JSON web token. So I'm going to call this auth payload. And what that means is just a JSON web token. But you'll see that we're going to have to create an actual class pretty soon to store our JSON web token. So our JSON web token is going to be hashed based on two values, the expiration date and also the user ID. So the expiration date, we can just say it's going to be some like distant future date. But the user ID is, of course, going to be our username, or actually our built-in ID rather, because right here, because this is a collection or a database, every single collection item will have a unique ID because we haven't guaranteed that the username will be unique yet, but the ID is absolutely going to be unique. So we'll get the ID, and then we can pass this into an auth payload that we'll define, and then we can return a response that contains the auth payload. So previously I was returning user, but now we really need to talk about two things. First of all, we need to talk about auth payload and how we define this. And so I'm going to do that right now. So let's go ahead and create another folder inside of our app. And we can call this folder auth because it's not a JSON web token is not obviously like a model, but it's not really a controller. It is some sort of object. It's just not in our database. So we can create a separate folder for this. And then I'll just call it something like JWT authenticator. Okay. And of course, we'll need JWT in order to use this. Oh, and there's no such model JWT. Okay. So first of all, let's make sure we add JWT into our dependencies. Cool. So is everyone following along? Okay. I'm just going to keep going, but you can check the slides. That has all this information as well. So we can just add the JWT class or framework rather. And this will install it and allow us to access it. Same thing over here. Ooh, okay. So now this should go away. Let's see, does it go away? Give it some time. It's failed to fetch. Ooh, did I misspell something? No, it's getting it. Okay, cool. So anyways, we'll of course import the standard things that we need. And then let's go ahead and create our auth payload. So our auth payload will be a struct. And I hope, does everyone know what a struct is? Yes, okay. A struct is kind of like a set of like variables inside of it. That makes sense. So we'll have two things inside of our struct. We'll have a expiration claim, which of course is when our JSON web token expires, and also the user ID. And then we can define a function called verify. And I'll just type this for you because this is, you don't really need to know how like specifically that part works because this is kind of built in to Vapor's JWT. But we'll verify that this JSON web token is not expired just like that. Okay, so that's great. So now we have our auth payload. Okay, so we got back here. Hopefully this starts to go away. Okay, should be going away. Cool. Okay, but how do I now pass this auth payload back, seeing that I created it? Because right now this is returning type user, and we don't want to return just the username and password of the user. We want to return the web token for the user, right? So let's go ahead and create something called a data transfer object. And those are abbreviated as a DTO. So if this is blowing your mind right now, just take a deep breath because it's not that difficult to understand. Okay. Um, Actually, let me see. Maybe we can get away with not creating a DTO. Um, yeah, you know what? Let's actually try not creating a DTO. So you guys don't need to worry about this. Instead, because a DTO is just a wrapper, it's basically just going to be a struct like user, but it'll contain like the auth payload inside of it. But instead of creating a DTO, how about we just, instead of responding with user, let's just respond with the built-in Vapor HTTP response type. Okay, so we can just create a response here. This is an HTTP response, so we'll give it a status. We can say okay, which is just going to be like 200. And then we will give it a JSON as our body. So we always have to apply the JSON header. And then we'll give it a body. So what will we put inside of the body? So should we respond after creating or after logging in? Should we respond with the user's password? Do you think that's like a good way of making an API? No, it's not. So maybe instead of responding with the user's password, of course, we want to give them the web token, right? So let's just create this will be a JSON response. And a JSON is basically like a Python dictionary. So like if you think of it that way, it'll make a lot of sense. So we'll give it a token, which is our auth payload. Okay. And right here, this just kind of puts it into the right format for our JSON to use. And then maybe we can also return like the user ID as well. So we just know which token this user belongs to. Okay, cool. But if we want to do that, we obviously have to get the user ID. And remember, we actually already did that in, where did we do that? Why am I blanking? I'm pretty sure we got the user ID from somewhere. Does anyone want to help me? Ah, right here, right? We did that right here. Okay, so um, we'll just do that again. So try this again, but here, try user ID. I'm sorry, let user ID equals try existing user. Cool. And this theoretically should always work, so I'm not going to guard it with anything. Great. So now we can return this response. So let's put the response in here. And we need to wrap it inside of a JSON encoder to convert this list into an actual JSON object. So we'll just do that. Cool. Okay, so now when we log in, we actually return like a properly formatted JSON response that contains the token and the user ID. But hold on, now like we need to fix these things as well. So let's just fix those things. We can just return like a response and another response here. And we probably should give it a status, right? So let's just say here, the status, because this means that the user did not exist. So we can say something like, we just use unauthorized, which I believe should be like 301 or something. Can't remember. Um, yeah. And then we can just say something like username does not exist. And then similarly over here, we can say something like password incorrect. Cool. And why is this? Call can throw, but not marked with try. Okay, let's mark it with a try. Yay, okay. Nice. So we have a register and a login API, or endpoints inside of our API. So does that all make sense so far to everyone? Yes? No? Okay, so I'm actually gonna pause here and we'll go back to our slides. Okay, so if you remember, we have to go to our, well, we created a controller, right? But we actually have to register our endpoints with our actual server. So right now, if you look at our server, our server is called app. And then we call this function routes on it, and that defines the routes. So far, the only routes that are part of our server are actually just these default routes, which we don't want. So we need to actually register our routes. So let's go ahead and register them. Okay, so you can follow this format. And we have two collections here, right? We have a users controller. And then we also want to register our restaurant controller. Restaurants controller. Cool. And then because we're using JWT, we want to define what our hashing algorithm is. So let's just do that like right over here. Signers use. We'll just use like SHA 256, very common hashing algorithm. That'll just convert the information we pass in into like a scrambled JWT token. And then you can define the signer key that you want to use to make this unique over here. Okay, great. So before I get into like the middleware part, first of all, does this make sense to everyone? Yes. Oh, time is up. We're out of time. No, okay, well, thank you guys for coming. I know there's a lot more that should be done in the backend, so please take a look at the slides and hopefully you guys know all the information you need to build there's only one more controller you need, right? Like a reviews controller and a reviews model. And then just check out the GitHub for one more function that I didn't talk about that should be put into this file. And that function will just be called the authenticate function, which means it'll be a function that authenticates the JWT on side of your protected routes. So if that doesn't make sense, don't worry, we'll probably cover it next time, or at least look at it on your own time inside the GitHub. But thank you guys so much for coming today, and hope you learned a lot about JWT, MVC, CRUD, HTTPS, API. Am I missing any acronyms?
Thank you guys so much for coming to today's session. I know it was long, but we had a lot of information to cover. And we also have boba today, so as a reward for sitting through and learning everything, you guys can come up and we have a few different flavors as well.
Yes.
What flavors do we have, Sam?
Oh, we have Thai tea, milk tea, and fruit tea, and yeah. Just pick whichever ones you want. Yeah.
Take one from here.
Oh, and I promised to talk about async await. So while you guys are getting boba, async await. Okay, fine. Never mind, guys. Next time. Oh, okay. Well, we can only do so much. Yeah.
Well, that was a lot of information. I think it was good.
Yeah.
We'll continue next time, and then maybe all like the styling stuff you can like.
Yeah.
I think this stuff is more important anyways.
Yeah, you're right.
No, I gotta go.
Oh, Sam, where'd you learn everything you were saying up there? How'd you get like so good at it?
CS35, ChatGPT, going to hack last year, you know?
I need to start doing that.
Yeah.
You're like, it just clicks for you. That's what that's like the point I'm trying to get to.
You know what? You should go to Hack on the Hill and then you'll like learn more. And
I'm planning to.
yeah,
Has the sign up started for that?
I don't think so, but it will start like
Okay,
pretty soon.
so
Yeah.
just keep posting on the Instagram.
Yeah.
Okay, perfect.
Yep.
What's your name? Jalen? Oh, yeah. Are you a first year? Yeah. Oh, really? Oh, I can see. Are you from Korea by any chance? Oh, yeah. Are you international or international? Oh, shoot. Hey, your English is really good too. You at international schools there? Yeah, they teach you in English. Yeah. Or is there an English class?
It's basically like using US
Oh, really?
GPA, APs,
Everything? So all classes are taught in English? Hey, no wonder. Do you miss Korea? Have you gone back yet? Like this whole quarter or the year? No?
No.
Bro, I'm always watching the Korean street food videos on YouTube.
Oh, which one?
Bro, have you seen that grandma that makes there's this grandma what's the famous Korean street the market called? It's the maybe that one. I don't know, they just have stands with tteokbokki and all the foods there.
Korean market foods are so good.
Yeah, bro, I need to go there. I went to Japan this summer. That was fun, but I need to visit Korea.
Oh, yeah, I should stop.
You miss home yet?
Miss it a lot.
I can stop it.
Like foods. They do have like Korean restaurants.
Okay, everyone. I hope you had a great long weekend. we're just picking up back where we left off during last session when I wasn't able to finish talking about async await and JWT. So we're just gonna do that really quickly as this short annex video before our next session where we will dive into how to deal with Swift UI. So for now, let's just quickly finish up what we were talking about when it came to JWT authentication and async await functions. So if you remember where we were previously, we talked about how we need to register our different API routes onto our backend, and we will collect the routes that are related to each model into a controller for that model, as you can see in our slides. And we also talked about the need for a middleware such as JWT Authenticator when we want to execute anything like a hook after our request. Okay, so one thing we haven't done yet is protecting routes. So let's go ahead and pick up back where we were in the code. Okay, so if you remember, we needed to edit the configure file and paste in our MongoDB connection string. So go ahead and do that. All right. And then if you remember, we had created a restaurant model to store restaurants in our Brew and Eats app. And we also created a restaurant controller where we can get our restaurants and we can post a new restaurant. All right, so that is great. And we also have a user model, which consists of a user, a password, and of course the unique ID. Same over here, we had the name, the URL, average rating, and the unique ID. And the user is controlled with the user's controller. And we had two methods. We had register and we had login. Okay, that's great. And then remember, we created an auth payload, and this auth payload would contain our JWT token or generate that JWT token using the expiration time and the unique ID that gets passed into it. And we will talk a little bit more about this in just a second. But first of all, let's fill in some of the things that we hadn't filled in yet in our users controller. So remember, when we register, we also wanted to check if the username is already taken. And in order to do that, we have to query our users database. And we actually already did this over here. So let's just paste this into the code and voila, we can check if a user already exists using this query. And we don't actually need to get the user, but we just need to check if that user exists. So we can just make this into an if statement. And then if the user already exists, we don't want to register the user again. So we can go ahead and return a response object. And remember, our HTTP response is going to give us a status code. So we can say, let's see, conflict sounds like a good status code to use. And then we'll give it a body. And let's just initialize it with a string. And we can just say username taken. Cool. So now this ensures that we don't re-register any users. And ooh, now we need to fix this, right? We don't want to return user, we want to return response. And that's the same format that we had in login. And this is important because originally we were returning the user model, which contains the password. And we don't want to do that in HTTP because it's dangerous to send the password over HTTP. So instead, if we successfully create a user, let's create a response object as well. This time, the status can be something like, let's see, what do we have here? Created. And then we can give it a body. And actually, let's follow the same format that we use for our login response because it's good to follow the same formatting. So we can say something like created. And over here, we had an object, specifically a JSON object. And JSON objects are formatted kind of like a Python dictionary. So we can just go ahead and pass one in here because it's doesn't need to be that long. I'll just directly type it in here. I'll just say something like user created. And honestly, that should be good enough. But because this encoding could fail, we have to put try over here. All right. So that just took care of something that we needed to take care of. And I think our users controller and our users model is completely done. Oh, wait, there's one thing that I forgot to mention. We have this validations function inside of user, and I pasted this in for you guys without explaining it, but let's explain it. So you can always add validations to a model in Swift, and a validation ensures that any instance of this model is going to conform to these tests. So, for example, the username cannot be empty. The password cannot be empty, and the password must be between 6 and 10 characters long. So let's go back to the user's controller and make sure that every time that we create a user, that's true. And the way that we can do that is by, first of all, validating whether or not the user matches the validations function. Okay, there it is. So what this does is it essentially attempts to decode the request as a user and also check the validations on it. So this will now make sure that every time that we create a user, it'll conform to our validations function. Finally, one thing that we should do when we create a user is to hash the password. And that can be done using this line right here. This will reassign the password field to this new hashed password so that if anyone breaks into our database, instead of getting the actual password, they will find a bunch of hashed passwords that will look like a lot of scrambled numbers, and they won't be able to steal the user's password because in order to log in, the password goes through a secret hash. And did we put it over here? Well, this is with our JWT, but it's the same concept. So that's why we are going to hash our password and reassign it when we create our user. All right. So like I said, we created last time our users controller and our restaurants controller. And pretty soon we'll talk about protected endpoints and also the reviews model and reviews controller. But for now, let's just make sure that these endpoints themselves actually work. So to do that, let's just start up our backend. It's already started by itself, just restart it. And I'm going to use an app called Postman. Now, Postman is a very useful utility that allows you to send HTTP requests to whatever URL or URI you want to. And so in this case, if you look over here, our server has started at this URL. And we know that these endpoints, which we can append to this URL, are what we want to send our HTTP requests to, in this case, the post request, in order to register and then to log in. So let's go ahead and register a user. Okay, so here I am in Postman, and I already have done a bunch of things, but if you just got in here, just click New, and then select Post Request. You'll paste in the URL of your server, then add the specific endpoint that you want to target. In this case, I want to register a user, right? And what is the format of the data? Well, it has to be JSON, and we can type it in raw. All right, so let's do that. And then what is this expecting? Well, we see that we're decoding our request as a user, and our user has two fields. Remember, the ID is automatically generated, the unique ID. So it only has two fields, which is the username and the password. And the password cannot be empty, and it must be between 6 to 10 digits long. All right, so let's go ahead and test out the register endpoint first of all. Let's create a new username. We can call this, I don't know, CS Legend, and then the password 1, 2, 3, 4, 5, 6, 7. All right, let's see. This is 7 characters long, so it's between 6 and 10, and neither the username or password are empty. So this should succeed. Okay, let's send it. Does it succeed? Yes, we get message user created, and we get the status code 201 created, which is exactly what we programmed right over here, where we get created, which it turns out to be 201 in its numerical form. And then we got our message user created. And now I just want to also add something. Because this is a JSON request inside of our headers, don't forget to add this specific key value pair, content dash type, and then application slash JSON. And in general, whenever you make HTTP requests using JSON data, you will have to add this header. So anyways, great. Now let's also make sure that it doesn't allow you to re-register the same username. So let's say I wanted to register this person again, and what will happen? Username taken, 409 conflict. Okay, that's what we coded right here. Conflict, username taken. So we know that it's actively querying the database and making sure that all the usernames that we create have not already been created in the past. Okay, and finally, we can ensure that, for example, a short password or a blank username won't work. And as it says, username cannot be empty, password must be between 6 to 10 long. And once again, That is a bad request. And notice that we didn't actually code that in here because that is automatically built in via the validate function, which comes with the validations function inside of our user model because we use this specific header that follows the validations protocol or the validatable protocol, which gives us this validations custom object that we can allow our user model to participate in. So it'll automatically send these specific error messages. And because our password was empty, or our username was empty, and our password was only 3 characters, both of these failure descriptions were sent back to us. So that's really handy, and it's one of the cool tricks that you can use in Swift. Okay, so we created a user successfully in the past. Hopefully you still remember the username and password for that. If not, just create another one. But I still remember. So now let's go to the login. So once again, make sure that we have content type application slash JSON as our key value pair. And then we'll go to our body. And this is still a post request, right? Okay, so we need to log in now. So we had CS legend. We want to log in to JSON raw. Okay, this is the endpoint. Yes, let's log in. And then what does it say in the body? In the body, this is important. We got back our token and a user ID. Interesting. So let's go over here. Is that what we coded? We return the JSON encoding of this, which is the user ID and the JWT token. Great. So everything seems to be functioning properly. What if the password is incorrect? Let's try that. Password incorrect. Okay. What if the username doesn't exist? Username does not exist. All right. So our user's controller is working perfectly. And then what about our restaurant controller? Okay. So here's our endpoint to get all the restaurants. So let's paste that in here. Ooh. Okay. What does it require? Well, a GET request actually doesn't need a body. So we'll just empty this. And then make sure we still have our application JSON header, although technically if we don't have a body, we don't really need that either. But we'll change this to GET. And let's see if we can get all the restaurants. Wow, here we go. All the restaurants in our Brew and Eats app. Hold up. If you're following along, you probably don't have any restaurants here because you haven't added any restaurants yet. So actually, let's first add some restaurants into our thing. So let's go over here. Okay. It's actually the same endpoint. Let's add a restaurant. This time we do want to make sure we have content type application JSON. And then how does our creation endpoint work? Well, it decodes the body that we post into a restaurant object. And how many fields do we have? 3. Name, image URL, and average rating. Okay. So make sure that that matches over here. Name. Let's see. What is a good restaurant? I'll say food truck. Image URL. For now, I'm just gonna put www. Actually, I'll just copy this Daily Bruin. I'm not sure this is for Bruin Cafe, but for the sake of this demonstration, we don't need to worry about that. Let's just paste it in here. And then let's see, average rating. I don't know. 1 is probably fine. Okay. Voila, we created a new object and it returned to us the name, ID, image URL, and average rating. Okay, cool. Okay, so that seems fine. Why is the image URL null? It might be because over here we added this question mark. Where if it's not, it equals null. Oh, I know why. I didn't capitalize correctly. So let's undo just what I did. Okay. Make sure you're following the exact formatting here. This question mark means that this field is actually optional. So we didn't need an image URL. But for the sake of this demonstration, let me just try this again. Okay, see now we have the image URL, the name, the average rating. So it works. That's great. Okay. Okay. But you might ask, where does the JWT come into play? Good question. Well, we got a JWT token when we logged in. And so far, these endpoints for the restaurants are exposed to anybody. So anybody who has these endpoint URLs can get all the information on our app. Do we want that? Maybe. Often, for example, GET requests can have no protection, but maybe to prevent people who are outside of our app ecosystem from creating reviews or even posting restaurants, we want to protect some of the endpoints with a JWT authentication token. And so during our next section, I'm going to talk about how to do that. Okay, so let's go ahead and create a review model. Hopefully you've tried to do this on your own, but if not, we're going to do it together. Okay, so as usual, we will import these things, and then let's go ahead and define how our view is going to look like. Okay, so we'll create a new schema in our database called reviews. As normal, it will have a unique identifier. And then how many fields will it have? Well, a review has to have a rating. So this is going to be an int. We can call it rating. And normally there's like a comment section. So I'll call it comment. And that should be a string. And then here comes the tricky part. A review has to be done by a specific user, right? Now I could just put field and put username or user ID. That's fine. But let's be more Swift-esque and actually link it to the other model. So I instead am going to put in this field called parent. And we will still call this, let's say, user ID. But now, oops, let's get this indentation all the same, if possible. There we go. Apologies. Okay. So what parent does is it requires you to pass in the unique ID of the user as another field. And then it'll allow you to get all the information for such as the username and password in the case of the user model, just from that unique ID that you pass in. Okay, so a rating has a user associated, and of course it has a restaurant associated with it as well. So let's also add restaurant ID as a similar field like that. Cool. Okay. So now what? Now we need to define our init function. So we need to initialize all of the fields. So the rating should just equal to the variable rating, comment equals comment. And then what about the restaurant it's associated with and the user it's associated with? Well, here's how we'll do this. We'll say user ID equals user ID. Oof. What is going on? There we go. And restaurant equals restaurant ID. Did I type this all correctly? Hold on. Ah, it's because we need to pass it in as our parameters. So, like I said, it's a unique ID, and so is restaurant ID. And rating and comments are integer and string. Awesome. So now we've defined our view model, and then we can go ahead and define our view controller. So let's do that. Okay, we will have a boot function where we can post reviews and of course get reviews. And I can do something like this. But this is not going to be the ideal format. So like I previously mentioned, we want to actually ensure that these endpoints are protected. So in order to protect an endpoint, we're going to say let protected equals API.group, and then we'll add our JWT authenticator in order to protect it. Now, JWT authenticator is the name of this file in which we have an auth payload, but we actually haven't defined any object called JWT authenticator. So let's go ahead and create a JWT authenticator struct. And what this will do is it will take that JWT token that we generated over here, and then it will authenticate it against a specific user. Because notice how here we give it a unique ID, but we're not actually connecting that unique ID to any model yet. And we want to connect that unique ID, of course, to the user model. Okay, so let's create an authenticate function. So the way that this is going to work is it's going to try to verify the JWT token and see if it's valid or not. Okay, so this is what our JWT authenticator should look like. And now when we go back to our review controller, we can create a protected endpoints in order to, for example, post a review. Okay, but now we need to modify how this works. So let's get to it. Ooh, okay, my computer just crashed, but I'm back and with some nice looking code as well. So as I was just now saying, we want to try making the review posting protected. And so we create this protected group with the JWT authenticator and then make the post endpoint fall under the protected group. And now that it's protected, we can require this auth payload .self, and specifically we'll get the unique ID from the auth payload before we decode the review. Then we'll decode the review, and then this unique ID, we can do a number of things with it. Currently, the review, of course, is structured like this with rating, comment, user ID, and restaurant ID. And so this means that when we do our post request, we need to fill in the rating, comment, user ID, and restaurant ID fields. Now, technically speaking, the token already contains the user ID. So if we wanted to, we could potentially make this an optional field. But what I'm going to do for now is just compare these two things. I'm going to compare the token user ID with the user ID actually passed in the request. And under a normal circumstance, the user that is actually creating a review should match the user ID that is passed in the request. This is a good way of checking for hacks or any illegal operations on your database, because the JWT token cannot be faked. So here what we're doing is we're checking the user ID with the actual unique ID in the JWT token. And if it all looks good, we'll just save our review into our database. And then over here, I've added logic on updating the average rating for the restaurant that the review refers to. And I'm not going to explain this because this is a lot of math, and that's not the point of our session. So please just take a look at it or copy and paste it from the GitHub repo. But this is an example of how we can create a protected endpoint. And let's go ahead and test it now inside of Postman. So if you remember, we logged in. And when we logged in, we got a JWT token. So let's copy that. Now we're going to create a review, and this is a protected endpoint. So we have to go to our headers and add another header called authorization. And then we'll paste in our JWT token after the word bearer. And then back in our body, remember our model has rating, comment, user ID, and restaurant ID fields. So we'll pass in a rating, a comment, and then the user ID and restaurant ID fields. Since these are parent keys, those are foreign keys, the way we'll structure it is it has to be an object named after the class. So restaurant and user, and then we'll pass in the unique IDs into these fields called ID. So the user, we can get our user ID from here, paste it in here. Great. Restaurant ID, let's just check the different restaurants that we have available and then just pick one. Let's see here, Ronde West. I'll get the restaurant ID and I will paste it into the ID field and then create a review. And voila, it was successful. For now, all it did was return the review for us, which is fine. Let's see. So this was, remember, Ronde West. Originally, its average rating was 0. We rated it 4, so now I would assume the average rating would become 2. Let's check. Ah, the average rating became 4. Probably because when it was initialized to 0, it actually didn't have any prior rating. Let's just verify this. I will now rate it in another review. So let me create a new user. Get that information. Okay, now let's see. Ronde West is now 2.5, which makes sense. So that means originally there were only 0 reviews. Then we added one, now there's 2. And you can see the average rating has been updated thanks to our controller logic. Awesome. So I'm going to leave it as something up to you guys to do to see if you want to protect both endpoints or even protect one of or both of the endpoints inside of the restaurant's controller. One thing also that you need to keep in mind is when you create your controller, so here I called it review controller, you need to register your controller in the routes app or in the routes function. So just like we did previously, make sure to register your new controller over here as well. Awesome. Okay, so we have just shown you how to integrate JWT authentication into your HTTP REST endpoints that you create via the controllers. Okay, so finally, we get to talk about my favorite thing, or what I implied I would talk about, but I didn't get the chance to during last session, which is async await. So assuming you created a nice backend, just like we did, that you've tested thoroughly with Postman and it works, how do you get that data into the front end? Well, you can use URL sessions and the async await syntax. The basic format that you should follow is first, you'll create your URL, which consists of the server URL with the specific endpoint, and then you'll create a URL session. You'll say try await URL session dot shared dot data from the URL. And then you'll get the data, and then you can decode the result into a model file in your front end. And just a little bit of more explanation on what this does. Essentially, you create a URL request, and then when you create a URL session, that is when you're actually communicating directly with the server, which is what we wrote just now. And it sends essentially the request as either a GET request or a different type of request depending on how you format the variables. So let's take a deeper look. So you can first have your URL request, and then you can pass in the body, and you will set the request method. So for example, a post request. And if you want to set key value pairs that will act as headers, you can set them as the set value function. And then you'll also pass in the body using the HTTP body field. And then once you've programmed your URL request, like we have here, over here, it was just .shared.data from URL, which means that's automatically a GET request. But if you want to make, for example, a post request or just a general request, the way you'll do it is you'll create a URL request object, and then you'll set its parameters, and then you'll pass it into the URL session. And this requires await because this is an asynchronous operation. You don't know how long it's going to take, but we just initialize the URL session with the request, and then the response status code and also the JSON body data will get passed to you as this tuple, which you can then decode to do whatever you want with. All right. As we can see, we're decoding it over here, just like we did in our backend. In our front end, we'll also have models, right? And we'll just decode those into our front end models. And then we can proceed to do everything we want to in the front end with those as well. So I'm going to leave this as an exercise of understanding for you to do because we don't have that much time. But in the front end, I want you inside of the Bruin Eats model to just write some functions that correspond exactly to what you see in the back end. So for example, for each endpoint in the back end, you have a create review, right? And then you also have get reviews. In the front end, you want to write functions that are the same in meaning. But in the front end, you're going to program first a URL request, and then you'll create the URL session where the URL itself is the actual API endpoint you created. All right, so that is all that I have for you this weekend, but hopefully during our upcoming in-person workshop where we talk about Swift UI, all of this will give you a solid foundation to understand how we jumped from our Vapor-powered backend to the wonderful Swift UI front end. Have a great weekend, guys.